Lesson 3.4 continued. Finding the equation of the tangent line to m of p at this particular point. Our first task is to find the slope of the tangent line, or the slope to the curve. We're going to use the quotient rule. I'm going to take my low function, p squared plus 3p, d high, the derivative of the top, 27p squared, minus 3, minus the higher function, 9p to the third minus 3p, d low, which is 2p plus 3, all over p squared plus 3p quantity squared. If you are finding slope at a particular point, it is most efficient for you at this point not to simplify, because that's a lot of crazy algebra. It makes more sense to just start with plugging in your value, since that's what I need to find, is the slope at a point. So this is a case where I'm not going to go to town and simplify first, because it'll be much easier to simplify later. Plugging in the 1 plus 3 gives me 4. 27 take away 3 gives me 24. Minus 9 take away 3 is 6. 2 plus 3 gives me 5. Over that 4 squared, which is giving me 16. Look how efficient it will be to get my slope. 24 times 4, 16, 1, 8, 96 minus 30 over 16, which gets me down to 66 divided by 16, and I'm not going to worry about simplifying that. I'm going to go to my tangent line and say y minus 3/2 equals, the slope is 66/16 times the quantity of x minus 1. And there's the equation of the tangent line. If it's a multiple choice, then you just might have to just quickly reduce to find a match. If f of x is equal to 10, this should be 10x e to the x, find an expression for f's derivative to the nth degree. Alright, so f of f's derivative at x. I'm going to start with the first derivative. This is a product, so I'm going to take my 10x as is. The derivative of e to the x is itself, plus now the derivative of the first, which is 10, times the second one as is. My second derivative, product rule again, so I get the same output, 10x e to the x plus 10 e to the x. That is just the derivative of this product. I still have to take the derivative of 10 e to the x, which is 10 e to the x. It repeats itself because of that constant multiplier. Combining like terms, I get 10x e to the x plus 20 e to the x. The third derivative, again, product rule, so 10x e to the x plus 10 e to the x. Derivative of the 20 e to the x becomes itself. Simplifying, I get 10x e to the x plus 30 e to the x. And at this point, you might see the pattern in what's going on for the derivatives. If you don't, you could keep doing a couple more derivatives. But the nth derivative of x is going to be that product, which is coming up in each derivative, plus 10 times the derivative I'm on, so 10n e to the x.